Hey, what's going on, guys? In this video we are going to see an example of short circuit method. Let's look at this problem. Here this question is asking, assume that the diode in the figure has V on is equal to 0.7 voltage but is otherwise ideal. Find the magnitude of the current I2 in milliampere is equal to what? Okay, here the question is asking for this current, and also they have mentioned that V on is equal to 0.7 voltage. So when the diode is on, we replace that one with 0.7 voltage drop. This happens when we have a practical diode. Now before we do this problem, let's look at the difference between ideal diode and the practical diode. So when we have ideal diode and if it's on or in forward bias, we replace that one with that actually short circuit, right? On, or we can say forward bias. If it's reverse bias or off, reverse bias, we replace that one with open circuit. But for a practical diode, if it's on or in forward bias, we replace that one with a short circuit, but we are going to have a 0.7 voltage drop. 0.7 voltage drop. So we replace with this one, replace that one with 0.7 voltage drop. And if it's off or in reverse bias, we replace that one with open. Okay, so this is the difference between ideal diode and the practical diode. Since they have mentioned V on is equal to 0.7 voltage, we know that this is a practical diode. Otherwise ideal, it means if it's off, it's going to be open, right? Now let's look at this one. We are going to replace, since we are doing short circuit method, we are going to replace this diode with a short circuit. Since this is a practical diode, we are going to replace that one with 0.7 voltage drop. So 0.7 voltage, and everything else is going to be the same. This is R1, 2 kilo ohm, and then here we are going to have the voltage, that is 2 voltage, and here we have the ground, and also we have R2, and that is equal to 6 kilo ohm, and I2 is flowing through this one. I2 is what we are trying to find. Now let's look at the voltages at the nodes. This voltage is going to be 2 voltage, because 2 voltage minus 0, that's going to be 2 voltage here. And here, since this is a voltage drop 0.7, 2 minus 0.7, that's going to give us 1.3 voltage right here. Okay, so we can apply KCL in order to determine whether this diode is on or off, because in order to have the diode to be on, we have to have a positive current through this one. So if the current is positive, it means it's on, because from anode to cathode, the direction, I put the direction depends on anode to cathode. If the diode is in opposite direction, we have to put the current in that direction, and whatever the direction we are getting, like we have to have the current positive. If the current is negative, it means diode is off. We have to replace that one with open circuit. And also we have to know the current here, because we are going to apply KCL. In that way we can figure out whether this is on or off. Now let's look at, let's say this current is I2. Let's say this current is capital I. This is I2, right? Now let's go ahead and create the equation. So first, if we apply KCL at this node, we are going to have I plus I2, because both of them are entering the node, is equal to current exiting the node, that is I. This is I2, this is, let's call this one I1, okay? Because this is I2. I1, I and I1 entering, I2 is exiting. For I, we can create the equation, or we can just leave it as I. I is what we are interested in, because we have to know whether it is positive or negative. So let's leave it as I. For I1, we can replace that one with 2 minus 1.3 divided by the resistance in between, that is 2K. So 2 minus 1.3 divided by 2K, that's I1. And I2 is going to be 1.3 minus 0 divided by the resistance in between, that's going to be 6K. So 1.3 divided by 6K. And here 2 minus 1.3, that's going to give us 0.7 divided by 2K, that's going to give us 0.35 milliampere. And this is I plus, and here we are going to have 1.3 divided by 6K, that gives us 0.22 milliampere. And therefore I is going to be 0.22 milliampere minus 0.35 milliampere, and that gives us a negative answer, right? it means we are going to have negative 0.13 milliampere. It means this is a negative current. Since we are having negative value for the current, it means this diode is off or reverse bias. It means we have to replace this diode with an open circuit. Now let's go ahead and draw the new diagram. If it's open, we are going to have a diagram like this, and now we have to figure out what is our I2 current is. Plus minus 2 voltage, and then this is connected to the ground, and then this is R2, that is equal to 6 kilo ohm, and then this is 2 kilo ohm, that is R1, and that's it. This is it, and we know the voltage here is going to be 2 voltage, and here since we don't have any voltage draw, this is 2 voltage, this is going to be 0. Okay, we can calculate this voltage using voltage division. Okay, let's go ahead, because voltage across this resistor is going to be the voltage here. So we can say 6 over 6 plus 2 multiplied by 2. That's going to give us 6 over 8 times 2. 6 over 8 is going to be 3 over 4 times 2, 3 over 2. So this is going to be 1.5 voltage here. So this is going to be 1.5 voltage. Therefore, I2 is going to be 1.5 minus 0 divided by 6. So this is going to be 1 over 4. That means 0.25 milliampere, because this is K, right? So 6K, it means 1 over 4 milli, because if you divide anything by K, that's going to be milli. So this is going to be 0.25 milliampere. That's going to be the I2 current. So I2 current is going to be equal to 0.25, and the unit is already milliampere, so this is 0.25 milliampere. And that's how we do this kind of problems. I hope this helps. Thanks for watching.